Killer bees, murder hornets. What are these fascinating creatures? How can we identify them? And how did they get their name? First, let's take a look at some of the differences between bees and hornets, or for that matter, killer bees and murder hornets. There are 5 main differences between bees and hornets. Bees die after they sting, hornets do not. Bees are both hairier and smaller. Bees have significant economic value. Hornets are of no importance to humanity. Bees build their nests out of wax. Hornets make theirs out of the wood-based pulp. Bees are far less aggressive than hornets. Before we get into the specifics behind murder hornets, let's take a look at the killer bee. The Africanized bee is also known as the Africanized honeybee. More commonly, it's known as the killer bee. The killer bee is a hybrid of the western honeybee species. It was originally produced by crossbreeding of the East African lowland honeybee with various European honeybees like Iberian honeybee and the Italian honeybee. The Africanized honeybee was first introduced to Brazil in the year 1956. Its introduction came as part of an effort to increase honey production. In 1957, 26 swarms escaped quarantine. Since then, the killer bee has spread throughout South America like wildfire, arriving in North America in the year 1985. The first hives were found in the United States and South Texas in 1990. Killer bees are much more defensive than other varieties of bees. They are far quicker to react to disturbances than European honeybees are. Once bothered, they will chase their victims for great distances, sometimes for more than even a quarter of a mile. Killer bees have killed around 1,000 humans to date. Killer bees are super aggressive and will sting their victims 10 times more than European honeybees will. Humans aren't their only victims though, as they're also responsible for killing horses and many other animals. Currently, there are 29 recognized subspecies of the killer bee. This number is based primarily on geographic variations, and all subspecies are cross-fertile. Geographic isolation has led to a wide variety of local adaptations. These adaptations include brood cycles synchronized with the bloom period of local plants, forming a winter cluster in colder climates, migratory swarming in Africa, long-distance foraging behavior in desert areas, and numerous other inherited traits. The killer bees in the Western Hemisphere originate from hives that were operated by biologist Warwick E. Kerr, when he interbred honeybees from southern Africa and Europe. Kerr was attempting to breed a strain of bees that could produce more honey in tropical conditions than the European strain of bee that was in use throughout North, Central and South America. The hives containing this particular killer bee subspecies were housed at an apiary near Rio Claro, São Paulo, in the southeast of Brazil. These bees were noted to be primarily defensive. Their hives had been fitted with individual excluder screens, called queen excluders, to prevent the larger queen bees and drones from getting out and mating with the local population of European bees. According to Kerr, in October of 1957, a visiting beekeeper noticed that the queen excluders were interfering with the worker bees' movement, so they were removed. This resulted in the accidental release of 26 Tanganyikan swarms. After this accident, the killer bee swarms spread out and crossbred with local European colonies. Since their accidental release, the descendants of these colonies have spread throughout the Americas. In the 70s, they moved through the Amazon basin, crossing into Central America in 1982, until they reached Mexico in 1985. Because their movement through these regions was quick and mostly unassisted by humans, killer bees have earned the reputation of being a notoriously invasive species. Killer bees arriving in the United States ignited a media firestorm in the late 70s, and it inspired several horror movies, such as The Swarm and The Deadly Bees, while sparking debates about the ability of humans to alter entire ecosystems. The first killer bees in the United States were discovered in 1985 at an oil field in the San Joaquin Valley of California. Bee experts believe that the colony didn't travel over land to get here. It's been suggested that they arrived hidden in a load of oil drilling pipe shipped from South America. The first permanent killer bee colonies arrived in Texas from Mexico in 1990. In the Tucson region of Arizona, a 1994 study of trapped swarms found that only 15% had been Africanized hybrids. This number had grown to 90% by 1997. What are the characteristics of killer bees? Though killer bees display certain behavioral traits that make them less than desirable for commercial beekeeping, and even though they use excessive defensiveness and love to swarm, they have now become the dominant type of bee for beekeeping in both South and Central America for several reasons. Mainly due to their ability to outcompete their European counterparts and their genetic dominance. Some beekeepers believe that they are also better pollinators and honey producers. There are several differences between killer bees and other Western bee types. Killer bees swarm more frequently and go further than other types of honeybees. Killer bees are more likely to migrate as part of a seasonal response to the lowered food supply. Killer bees are more likely to abscond, meaning that the entire colony leaves the hive and relocates as a response to stress. Killer bees have greater defensiveness when in a resting swarm compared to other honeybee types. Killer bees live more often in ground cavities than the European types. Killer bees guard the hive aggressively, with a larger alarm zone around the colony. Killer bees have a higher proportion of guard bees within the hive. Killer bees deploy in more significant numbers for defense and pursues perceived threats over much longer distances from the hive. Killer bees can't survive extended periods of forage deprivation. This prevents their introduction into areas with harsh winters or arid late summers. Killer bees have been deemed an invasive species in the Americas. As of 2002, killer bees have spread from southern Brazil to northern Argentina, and then north to Central America, Trinidad, Mexico, Texas, Arizona, Nevada, New Mexico, Florida, and Southern California. Once they reached eastern Texas, their expansion stopped for a while, probably because of the large population of honeybee hives within the vicinity. However, discoveries of killer bees in southern Louisiana shown that they have gotten past this barrier. In June 2005, it was found that the killer bees had entered Texas and then spread into southwest Arkansas. Commissioner Bob Odom of the Louisiana Department of Agriculture and Forestry said on September the 11th, 2007, that killer bees had established themselves in the New Orleans area. In February 2009, killer bees were discovered in southern Utah. By May of 2017, the bees had spread into 8 counties in Utah, as far north as Grand and Emery counties. According to Georgia's Department of Agriculture, in October 2010, a 73-year-old man was killed by a swarm of killer bees while he was clearing brush on his South Georgia property. In 2012, Tennessee state officials reported that a colony was discovered for the first time in a beekeeper's colony in Monroe County, in the east part of the state. In June of 2013, 62-year-old Larry Goodwin of Moody, Texas, was killed by a swarm of bees. In May of 2014, Colorado State University confirmed that bees from a swarm that aggressively attacked an orchardist in west-central Colorado were from an Africanized hive. Upon this discovery, the colony was destroyed. In tropical climates, killer bees effectively outcompete European bees. During their peak rate of expansion, they spread north at about 1 mile per day. Discussions were had about slowing their spread by placing a substantial amount of docile European strain hives at strategic locations, particularly at the Isthmus of Panama. Still, various national and international agricultural departments couldn't stop the bees' rapid expansion. Modern knowledge of the genetics of these bees suggests that such a strategy, had it been tried, wouldn't have been successful. As the killer bee migrates further north, colonies continue to interbreed with European honeybees. During a 2004 study conducted in Arizona, it was observed that swarms of killer bees could easily take over weakened European honeybee hives by invading the colony, then killing the European queen and establishing their queen. Currently, there are relatively stable geographical zones in which either killer bees dominate, a mix of the killer and European bees are present, or only non-killer bees are found, as is the case in northern North America and the southern portions of South America. Killer bees will abandon their hive and any food store to start over in a new location more readily than European bees. This isn't necessarily a severe loss in tropical climates where plants bloom all year, but in more temperate climates, they can abandon the colony with not enough stores to live through the winter. As a result, killer bees are expected to be a hazard mostly in the southern parts of the United States, reaching as far north as the Chesapeake Bay in the east. Cold weather limits of the killer bee have caused some professional bee breeders from Southern California into the harsher wintering locations of the northern Sierra Nevada and the southern Cascade Range. This is a very difficult area to prepare bees for early pollination placement, as is required for almond production. The reduced available winter forage in Northern California means that killer bees must be fed for their first spring build-up. The arrival of the killer bee in Central America is threatening the ancient art of keeping stingless Melipona bees in log gums, even though they don't directly compete with each other or interbreed. The honey production from a single hive of killer bees can be 100 kilograms annually and far exceeds the much smaller 3 to 5 kilograms of the various Melipona stingless species. As a result, economic pressures are forcing beekeepers to switch from the traditional bees of their ancestors to the new reality of the killer bee. Whether or not this will lead to their extinction is unknown. Thankfully, they are well adapted to live in the wild, and there are many indigenous plants that the killer bees don't visit. For now, their fate remains to be seen. That's pretty much all you need to know about killer bees. Murder hornets, however, seem like a brand new menace. Are they? Well, the answer is yes and no. The scientific term for the Asian giant hornet is the Vespa mandarinia. It can also be referred to as the Japanese giant hornet, and now the far more colourful of monikers, the murder hornet. It should be clarified that these insects are not new. They have existed for quite a long time, just not in the United States. The murder hornet is the world's most gigantic hornet. They're native to temperate and tropical East Asia, mainland Southeast Asia, South Asia, and parts of the Russian Far East. It was discovered in the Pacific Northwest of North America in late 2019, with 2 additional sightings in 2020. Murder hornets like to live in low mountains and forests, while almost wholly avoiding plains and high-altitude climates. Murder hornets create nests by digging, co-opting pre-existing tunnels dug by rodents, or occupying spaces near rotted pine roots. They feed primarily on bigger insects, colonies of other eusocial insects, tree sap and honey from honeybee colonies. The hornet has a body length of 1.8 inches, a wingspan around 3 inches, and a stinger that measures to be about 1/4 of an inch long. Murder hornets use this hefty stinger to inject large amounts of potent venom. Murder hornets are frequently confused with the yellow-legged hornet, also known as the Asian hornet. Asian hornets are an invasive species that is of significant concern across Europe, including the United Kingdom. Murder hornets are a species of the genus Vespa, which comprises all true hornets. Along with 7 other species, murder hornets are a part of the Vespa tropica species group. They are defined by a single notch that's located on the apical margin of the 7th gastral sternum of the male. The most closely related species within the species group is the Vespa sora. The triangular shape of the apical margin of the clypeus of the female is diagnostic. The vertex of both species is enlarged, and the shape of the apex of the Aediagus is distinct and similar. The division of the genus into subgenera has been attempted in the past, but has been abandoned because of the anatomical similarity among species and the fact that their behavioural similarity isn't associated with the evolutionary history of the organism. Regardless of sex, the head of a murder hornet is a shade of light orange, and its antennae are brown with a yellow-orange base. Its eyes and ocelli range from black to dark shades of brown. Murder hornets are distinguished from other hornets by their pronounced clypeus and their large gennae. Its orange mandible is home to a black tooth that it uses for digging. The thorax is a dark shade of brown, with 2 grey wings varying in spans of up to 3 inches in length. Its forelegs are brighter than the mid and hind legs. The base of the forelegs is darker than the rest. Their abdomens alternate between dark brown or black bands, and a yellow-orange hue that remains consistent with its head colour. The 6th segment is yellow. Its stinger is typically 1/4 of an inch long and contains a powerful venom that, in cases of multiple hornets stinging simultaneously, can kill a human. The queens are considerably larger than workers. Queens can exceed 2 inches in length, while workers are just 2 inches in length. The reproductive anatomy is consistent between the two, but workers don't reproduce. Male drones are similar to females, but they lack stingers. This feature is consistent among the large order of insects known as the Hymenoptera. The murder hornet is found primarily in the Primorsky Krai, the southern part of Khabarovsky Krai, and the Jewish Autonomous Oblast regions of Russia. In Korea, murder hornets are referred to as general officer hornets. They're known as the giant tiger-head bee in China and Taiwan. The murder hornets can also be found in Thailand, Laos, Cambodia, Vietnam, Myanmar, India, Nepal and Sri Lanka. They're common in Japan, where it prefers rural areas where it can find trees to nest. The Japanese call this insect the Osasumabachi, which literally translates to giant sparrow bee. By the year 2008, some popular media outlets in Japan also referred to this wasp as Satsujin Susumabachi, and that translates to, you guessed it, murder hornet. And that was the name that was passed along to a New York Times reporter in 2020. Murder hornets have been found 4 times in the Vancouver area in September 2019 in Nanaimo, British Columbia, in December 2019 in Blaine, Washington, on the United States side of the border adjacent to Vancouver Island, and 2 specimens collected in May 2020, one from Langley, British Columbia, about 8 miles north of Blaine, and one from Custer, Washington, 9 miles southeast of Blaine. Laboratory findings indicate that the specimens collected in 2019 from British Columbia and Washington were from different colonies. This suggests that 2 simultaneous introductions of the murder hornet happened in North America within about 50 miles of one another. In April of 2020, authorities in Washington asked members of the public to be alert and report any sightings of these deadly wasps, which were expected to become active in April if indeed they were in the area. If they were to become established, it's believed that these insects could decimate bee populations in the United States and establish such a deep presence that all hope for eradication could be lost. As a result, there is currently a full-scale hunt for the species underway by the Washington State Department of Agriculture. Reports of murder hornets from other parts of the world appear to be erroneous identifications of other hornet species, like the Vespa orientalis and Vespa velutina in Europe. Murder hornets prefer to nest in lowland forests and low mountain foothills. Murder hornets are an extremely dominant species. No efforts are being made toward conserving them or their habitats, as they are common in areas of low human disturbance. Unlike other species of Vespa, murder hornets almost exclusively inhabit subterranean nests. In a study of 31 nests, 25 were discovered around rotten pine roots. In addition to that, snakes, rodents, or other burrowing animals had previously made some of the tunnels the hornets use. The depth of these nests was between 2.4 inches and 23.6 inches. The ground entrance surface varies in length from 2 centimetres to over 23 inches, either horizontally, inclined or vertically. The queens that found the nest prefer narrow cavities. The nest of a murder hornet typically lack a developed envelope. During the initial stages of development, the casing is in an inverted bowl shape. As the nest grows, anywhere from 1 to 3 rough sheets of combs are created. Frequently, single primordial combs are designed simultaneously before being fused into a single comb. A system of one central pillar and secondary pillars are used to connect the combs. Nests typically have 4 to 7 combs. The top comb is abandoned after summer and left to rot. The most extensive comb is at the middle to the bottom section of the nest. The most massive combs created by murder hornets measured nearly 19.5 inches by almost 18 inches. It was home to 1,192 cells. The nesting cycle of a murder hornet is relatively consistent with that of other eusocial insects. 6 phases occur in each period. Inseminated and unseminated queens enter hibernation after a specific cycle. They will first appear in early to mid-April and start feeding on the sap of oak trees. Although this timing is consistent among hornets, murder hornets dominate the order, receiving preference for premium sap sources. There is a queen's dominance hierarchy among the murder hornets. The top-ranked queen starts feeding, while the other queens form a circle around her. Once the top queen finishes, the second highest-ranking queen feeds. This process repeats until the last queen has fed. Inseminated queens start to search for nesting sites in late April. The uninseminated queens do not search for nests since their ovaries never fully develop. They continue to feed, but then disappear in early July. An inseminated queen begins to create relatively small cells in which she raises around 40 little workers. Workers do not start to work outside of the hive until July. Queens participate in activities outside the hive until mid-July, when they stay inside the nest and allow workers to perform all other activities. By the time that early August arrives, a fully developed nest will be in place, containing 3 combs holding 500 cells and 1,000 workers. No eggs are laid after mid-September, and the focus then shifts to caring for the larvae. The queens die in late October. New queens and males begin to take on their responsibilities in mid-September and mid-October respectively. Their body colour becomes intense during this time, and the weight of the queen will increase by about 20%. Once the queen and the males leave the nest, they do not return. In the world of murder hornets, males will wait outside the nest entrance until the queen comes out. Once the queen emerges, males will try to intercept her mid-air, bring her to the ground and copulate from 8 to 45 seconds. Afterward, the male returns to the entrance for another chance, while the queen exits. Many queens try to fight off the males and leave unfertilized. After this cycle, queens can be found in moist subterranean habitats. When sexed individuals emerge, workers shift their focus from animal foods and protein to carbohydrates. The last sexed individuals to appear will die of starvation. Let's take a closer look at the dangerous stinger of a murder hornet. The stinger of the murder hornet is about 1/4 inch long. It injects an especially powerful venom that contains, like many bee and wasp venoms, a cytolytic peptide, specifically a mastaparin, that can damage tissues by stimulating phospholipase action to its phospholipase. The stinger of a murder hornet is about 0.18 inches longer than that of a honeybee. What does it feel like to be stung by one of these nasty creatures? Something tells me that's something we never want to find out. However, an entomologist at Tamagawa University named Masato Ono described the sensation of being stung as feeling like a hot nail being driven into my leg. Yikes! A murder hornet's venom contains a neurotoxin called Mandara toxin, a single-chain polypeptide. While a single murder hornet can't inject a lethal dose, it can be harmful even to people who aren't allergic if the dose is sufficient enough, as is the case of multiple stings being received. However, if the victim is allergic to the venom, this dramatically increases the risk of death. Tests involving mice showed that the venom falls short of being the most lethal of wasp venom, having a deadly dose of 4 milligrams. In comparison, the most poisonous wasp venom, at least to lab mice, by weight belongs to Vespa luctuosa at 1.6 milligrams. The potency of the murder hornet sting is due to the relatively large amount of venom that they inject. Since the year 2001, the yearly human death toll caused by stings of bees, wasps and hornets in Japan has been ranging between 12 and 26. Since this number also includes deaths caused by wasps, bees and other hornet species, the number of deaths caused specifically by murder hornets is likely to be significantly lower. China has explicit advice for people encountering murder hornets. Those who are stung more than 10 times should seek medical help and need emergency treatment for more than 30 stings. The stings can cause kidney failure. In 2013, stings by murder hornets killed 41 people and injured more than 1,600 people in Shanxi, China. Fatalities from envenomation are mainly related to anaphylactic shock or heart attack. Deaths have happened as a result of multiple organ failure, which typically happens after a large number of stings. All sting victims exhibit signs of skin hemorrhaging and necrosis, though both are otherwise rare. The two likely reasons for skin hemorrhaging and necrosis are an inability to effectively neutralize the venom, or unusually potent venom toxicity for that set of stings. In either case, these stings lead to multiple organ injury. While not everyone stung displayed lesions or necrosis, a strong correlation existed between the number of stings and the severity of the damage. Those who died, on average, were stung 59 times, with a standard deviation of 12, while those who survived suffered 28 stings, with a standard deviation of 4. Murder hornets also have parasites. Xenos mutoni is a common parasite among the Vespa species. During a study of pests who thrive among species of Vespa, 4.3 of female murder hornets were parasitized. Males were not parasitized by creatures such as Xenos mutoni at all. The significant consequence of being parasitized is the inability to reproduce for the following year. Parasitized queens follow the same fate as uninseminated queens. They do not search for an area to create a new colony and feed on sap until early July, when they disappear. In other species of Vespa, males also have a chance of being parasitized. The consequences between the two sexes are similar, as neither sex is able to reproduce. How do murder hornets communicate? Murder hornets use both visual and chemical cues as a means of navigating itself and others to the desired location. Scent marking was discussed as a way for hornets to direct other members of the colony to a food source. Even with antennae damage, a murder hornet was able to navigate itself. It was unable to find its destination only when vision impairment was induced. This implies that while chemical signaling is essential, visual cues play an equally important role in guiding individuals. Other behaviours include the formation of a royal court, consisting of workers that lick and bite the queen, thereby ingesting her pheromones. These pheromones could directly communicate between the queen and her court, or indirectly between her court and other workers due to the ingested pheromones. This is merely speculation, as no direct evidence has been collected to suggest the latter. Murder hornets communicate acoustically as well. When larvae are hungry, they scrape their mandibles against the walls of the cell. Furthermore, adult hornets click their mandibles as a warning to other creatures that encroach upon their territory. Murder hornets are the only species of social wasp known to apply a scent to direct its colony to a food source. The wasp secretes the chemical from the 6th sternal gland, also known as a Van der Waals gland. This behaviour is observed during autumnal raids after the hornets begin hunting in groups instead of individually. The ability to apply scents may have arisen because the wasp relies heavily on honeybee colonies as its primary food source. A single wasp is unable to take on an entire colony of bees because species, such as Apis cerana, have a well-organised defence mechanism. Honeybees swarm one wasp and flutter their wings to heat up the wasp and raise carbon dioxide to a lethal level. So organised attacks are much more effective and easily devastate a colony of tens of thousands of honeybees. In an experiment observing 4 different species of Vespa, including Vespa ducalis, Vespa crabro, Vespa analis and murder hornets proved to be the dominant species. Multiple parameters were set to determine this. The first set parameter observed interaction-mediated departures, which are defined as scenarios wherein one species leaves its position due to the arrival of a more dominant individual. The proportion of interactive mediated departures was the lowest for murder hornets. Another measured parameter was attempted patch entry. Over the observed time, interactions with the same species resulted in refused entry, far more than interactions with different species. Lastly, fights between these hornets, Pseudotori narina japonica, Niope goshkevichi and Lethecicelis were observed. And once more, the murder hornet proved to be the most dominant species. In 57 separate fights, 1 loss was found to Niope goshkevichi, giving the murder hornet a win rate of 98.3%. Based on interaction-mediated departures, attempted patch entry, and interspecific fights, murder hornets are easily the dominant species. What do these beasts eat? The murder hornet is intensely predatory. It hunts medium to large size insects, such as bees, other hornet species, and mantises. The latter are favourite targets in late summer and fall. Giant insects, such as mantises, are key protein sources to feed queen and drone larvae. Workers forage to feed their larvae, and since their prey can include crop pests, the hornets are sometimes regarded as beneficial. This hornet often attacks both colonies of other Vespa species and honeybee hives to obtain the adults, pupae and larvae as food for their larvae, and sometimes they also cannibalize each other's colonies. A single scout, sometimes 2 or 3, cautiously approaches the hive, producing pheromones to lead its nestmates to the hive. The hornets can devastate a colony of honeybees, especially if it is the introduced western honeybee. A single hornet can kill as many as 40 bees per minute because of its large mandibles, which can quickly strike and decapitate prey. The honeybees' stings are ineffective because the hornets are 5 times their size and heavily armoured. Less than 50 murder hornets can exterminate a colony of tens of thousands of bees in a few hours. Murder hornets can fly up to 60 miles in a single day at speeds up to 25 miles per hour. The slightly smaller Asian hornet similarly predates on bees and has been spreading throughout Europe. Murder hornet larvae, but not adults, can digest solid protein. Adult murder hornets can only drink the juices of their victims, and they chew their prey into a paste to feed to their larvae. The workers dismember the bodies of their prey to return only the most nutrient-rich body parts, such as flight muscles, to the nest. Larvae of predatory social vespids generally secrete a clear liquid, sometimes referred to as Vespa amino acid mixture, the exact amino acid composition of which varies considerably from species to species, and they produce to feed the adults on demand. Beekeepers in Japan attempted to introduce Western honeybees for the sake of their high productivity. European honeybees have no innate defense against the hornet, which can rapidly destroy their colonies. Although a handful of murder hornets can easily defeat the uncoordinated defenses of a European honeybee colony, the Japanese honeybee has an effective strategy. When a hornet scout locates and approaches a Japanese honeybee hive, she emits specific pheromonal hunting signals. When the Japanese honeybees detect these pheromones, 100 or so gather near the entrance of the nest and set up a trap, keeping the entrance open. This permits the hornet to enter the hive. As the hornet enters, a mob of hundreds of bees surround it in a ball, completely covering it and preventing it from reacting effectively. The bees violently vibrate their flight muscles in much the same way as they do to heat the hive in cold conditions. This raises the temperature in the ball to the critical temperature of 115 degrees Fahrenheit. In addition, the honeybee's exertions raise the level of carbon dioxide in the ball. At that concentration of CO2, they can tolerate up to 122 degrees Fahrenheit, but the hornet cannot survive the combination of high temperatures and high carbon dioxide levels. Some bees do die along with the intruder, much like when they attack other intruders with their stings, but by killing the hornet scout, they prevent it from summoning reinforcements that would wipe out the entire colony. Detailed research suggests this account of the behavior of the bees and a few species of hornets is incomplete, and the bees and the predators are developing strategies to avoid expensive and mutually unprofitable conflict. Instead, when bees detect scouting hornets, they transmit an "I see you" signal that commonly warns off the predator. Another defense used by honeybees is speeding up dramatically when returning to the colony to avoid mid-air attacks. How do you kill murder hornets? As of 1973, 6 different methods were used to control hornets in Japan. Though these methods lessen the damage caused by murder hornets, managing them is difficult. Let's go through the various ways of dealing with murder hornets. Beating them. Hornets are crushed with wooden sticks with flat heads. Hornets do not counterattack when they are in the bee hunting phase or the hive attack phase, but they aggressively guard a beehive once they kill the defenders and occupy it. The most significant expenditure in this method is time, as the process is inefficient. Nest removal. Applying poisons or fires at night is an effective way of exterminating a colony. The most challenging part about this tactic is finding the hidden nests. The most common method of discovering nests is giving a piece of frog or fish meat attached to a cotton ball to a wasp and following it back to its nest. With murder hornets, this is particularly difficult, considering its typical home flight radius of 1 to 2 kilometers. A murder hornet can travel up to almost 9 miles away from the nest. Bait traps. Bait traps are placed in apiaries. The system consists of multiple compartments that direct the hornet into a single hole which is difficult to return through once it is in the cul-de-sac compartment. An area located at the top of the box which bees can escape from through a mesh opening. Wasps cannot due to their large size. Baits used to attract the hornets include a diluted millet jelly solution, crude sugar solution with a mixture of intoxicants, vinegar or fruit essence. Mass poisoning. Hornets at the apiary are captured and fed a sugar solution or bee that has been poisoned with malothian. The toxin is expected to spread through trophallaxis. This method is useful in principle, but hasn't been extensively tested. Trapping at hive entrances. Traps are attached to the front of beehives. The effectiveness of the trap is determined by its ability to capture murder hornets while allowing bees to escape easily. Let's say a murder hornet enters the trap and catches a bee. When it tries to fly back through the entrance of the hive, it hits the front of the trap. The murder hornet will then fly upwards to escape and enters the capture chamber, where the hornets are left to die. Some hornets find a way to avoid the trap through the front, so these traps can be very inefficient. Protective screens. As discussed earlier, if met by resistance, murder hornets lose the urge to attack and will instead retreat. Different measures of strength include fishing nets, wire, weeds, or limiting the passage size so only bees can make it through. Experienced murder hornets catch on and eventually stay on these traps, waiting for bees to arrive. The best method of controlling murder hornets is the combination of these protective screens with traps. Human consumption. In some Japanese mountain villages, murder hornet nests are excavated, and the larvae are considered a delicacy when fried. In the central Chubu area, murder hornets are sometimes eaten as snacks or used as an ingredient in drinks. The grubs are frequently preserved in jars, pan-fried or steamed with rice, to make a savoury dish called hebo gohan. Adult murder hornets are fried on skewers, stinger and all, until their bodies become crunchy. Something tells me that right about now, you're anything but hungry. Murder hornets are fascinating and frightening creatures. As with anything, the more we know about animals like this, the better we can deal with their threat. Be safe out there